Hello everyone. We have a question. The equation of the curve is y is equals to 2x square plus m in the bracket 2x plus 1 where m is a constant, and the equation of the line is y is equals to 6x plus 4. So basically we have two equations, equation of curve and equation of line. The condition that they have given us is that show that for all values of m, the line intersect the curve at two distinct points. That means we have to show that if we take any value of m, the line and the curve will definitely intersect at two distinct points. We have to show that for all values of m. Because it is about two distinct points, that means point of intersection, that means common points of very first step that equate both the equations. Equation of the curve, which is 2x square plus m bracket 2x plus 1 over here, make it equal to the equation of the line 6x plus 4 over here. Open up the bracket. After opening the bracket, just rearrange them so that it becomes a proper quadratic equation form like 2x square. It was 2mx and we have negative 6x. It contains x, both of them x as common. We are left with 2m minus 6 and m minus 4. That means a proper quadratic form we have, where a is 2, b is 2m minus 6 and c is m minus 4. The condition was two distinct points. That means the discriminant is greater than 0, because when we have two distinct points, definitely the discriminant is greater than 0. Now place the values of a, b, c, and the value of a is 2, the value of b is 2m minus 6, the value of c is 2m m minus 4. Place it in this discriminant, and after that rearrange them and simplify them like 2m minus 6 with a square, which is actually the value of b square. Use the formula a minus b whole square, which is a square. 2m with a square is 4m square minus 2ab, 2 times 2m minus 2 times 2m times 6 would be 24m, and then we have b square, that means 6 square is 36, and then 4 times 2 with m minus 4 we get this result. Rearrange them, and after rearranging them we have a condition where it is 4m square minus 32m plus 68 greater than 0. As we can see, we can take 4 as a common and we can ignore the 4 because the equation is really too big. So try to make the equation as simple as you can so that your working would be less. So just take 4 as a common, because 32 is a multiple of 4, as well as 68 is also a multiple of 4. So taking 4 as a common and then dividing both sides by 4. So dividing over here by 4 would be 1 and dividing 0 by 4 would be 0. So finally we have a proper quadratic equation, which is m square minus 8m plus 17. So this is basically a quadratic equation in the form of m, and the question said that show that for all values of m, the line intersect the curve at two distinct points. Now we don't have to find the set of values, we don't have to find the values of m. We have to show that if we take any value of m, the line and the curve will intersect at two distinct points. So this is basically an equation greater than 0 for two distinct points. So what we will do, if we have such kind of condition where we have to show that for all values of m, because now you have a proper quadratic equation in the form of m, just convert this into a completing square form. Why? Let me give you an example answer for that. First of all, just check out the value, the coefficient of m square is 1. Then just look at the coefficient of m, which is negative 8, divide that by 2 and square it, and after that simplify that. It would be 16. As per rule, add and subtract this 16 in this particular quadratic equation, as we have done over here. M square minus 8m and this plus 17 at the m, adding 16 and subtracting 16, and after doing so, whatever we have added along with m square minus 8m. This m square minus 8m plus 16 is basically a perfect square according to the formula a square minus 2ab plus b square, which can be converted to a minus b whole square, and that would be m minus 4 whole square, because 16 is b square, so b would be 4 over here, and this negative 16 plus 17 would be positive 1 greater than 0. That finally we are at the last point of discussion. We can say that the minimum point of this particular curve, why minimum point? Because the coefficient of m is 1, so definitely you will have a u-shaped graph. You will have a u-shaped graph. So definitely when you have a u-shaped graph, definitely the turning point, or we could say the stationary point, or the vertex we could say, will be minimum. So because over here it is negative 4, the x coordinate of the turning point would be simply positive 4, and the y coordinate will be positive 1. So 4 comma 1 is the minimum point. If we just draw a sketch of this particular quadratic equation for a minimum point of 4 comma 1, we have observed that the graph that we have made is a u shape because the coefficient of m square is 1. Secondly, the minimum point is 4 comma 1, so that means the graph is above the x-axis. The inequality says that it is greater than 0, and when it says that greater than 0 means positive. So that means if you take, because over here x is represented by m, so over here m, and definitely we have y over here, and the inequality is greater than 0. From here, from the graph, you could easily see that if you take any value of m, the y will always be positive and it would always be greater than 0 according to the given inequality. That means if you take any y, as per the statement that show that for all values of m, that means any value of m, so the according to the condition, as I said, this is a condition of two distinct points, and the inequality says that it is greater than 0, and the graph also says that if you take any value of m, the y will always be positive, it would be always greater than 0. So it is true for any value of m that the inequality is greater than 0, and when we say that this inequality is true for any value of m, but this inequality is for the two distinct points, so therefore finally we can say that for all values of m, definitely we get two distinct points. We can also look this in another way as well. If we just look at this particular form, m minus 4 with a square and plus 1 greater than 0, this condition is a square. That means if we take any value of m over here, no matter it is positive, negative, whatever the value, after subtracting from 4, no matter your answer become positive or negative, but when you square it, the result is always positive. And when the result is always positive, and when you add 1 to it, the final answer over here is always positive. And when it is always positive, that means it is greater than 0. That means this inequality is true for any value of m, and definitely we can observe from the equation as well as from the graph that for any value of m, the graph and the line intersect at two distinct points.